Welcome back to our videos of our notes here. And today, what we're going to be doing is learning some shortcuts for derivatives. So, a reminder, a derivative is just the slope of a tangent line, but we have currently this big, giant, gross limit formula that we need to use in order to find um, our slopes of our tangent lines. And so we're going to be looking at some shortcuts. So, unless a question asks you to use definition of a derivative, you are welcome to use these shortcuts from now on. Do not bother with the limit unless the question specifically asks you to do so. Okay. These are much easier. All right. So, we're going to take a look at a couple of these and just sort of show you how they work. So the first one is the derivative of a constant function. So if I have a straight line, a horizontal line, if I draw slopes or tangent lines, the slopes for all of these is 0. So the slope of this function itself is 0, but also the derivative or the slopes of the tangent lines is 0. So what that means is if you find the derivative of a constant, this is 0. So for example, if I ask you to find the derivative of 6, this is 0. Okay? So again, dx means find the derivative of this thing. So this is find the derivative of a constant c, or in my example, find the derivative of 6, and I would get 0. Okay? If I have some value x, okay, as my function, that's a straight line, and the slope of this straight line is 1. Therefore, if I draw tangent lines anywhere along this line, those will also have a slope of 1. So the derivative of x is just 1. Okay. Another way of writing this is if f of x is equal to x, f prime of x is equal to 1. Okay. The next one is the power rule. You will use this a lot. Okay. So the derivative of x squared is 2x. The derivative of x cubed is 3x squared. The derivative of x to the power 4 is 4x cubed. So I'm going to give you a moment to write down what do you think the power rule is if you're taking the derivative of any x to the power of some number n. Try predicting here what this is going to be. Okay, if you need more time, please pause the video, write it down, and then start playing again. So you'll notice here that the 3 is in front. That was my original exponent. And now my exponent has been reduced by 1. For x to the fourth, the 4 is in front. That was originally my exponent. And the exponent has been reduced by 1. So if I'm finding the derivative of some x to the power of a number n, the n drops down to the front, and then my new exponent is 1 less than I started with. Okay? So if I want to find the derivative of these functions here, the derivative f prime of x to the power of 5 would be bringing the 5 down, and then we would have x to the power of 4, 1 less than we had. The next one, we've been given y, so our derivative is y prime. We'd bring the 1,000 down, and then we would have an exponent of 1 less. The next one is a little bit tricky. You will see lots of these types of questions as you proceed through the course. I would suggest rewriting this as x to the power of negative 2. Then when we find y prime and we bring the exponent down, we get negative 2 in front with an x, and then we have to reduce our exponent by 1. Remember, when you reduce a negative by 1, this is going to become negative 3. Negative 2 minus 1 gives us negative 3. Then We can rewrite this as -2 over x cubed. Notice that the negative in the exponent is only being applied to the x, not to the -2. Okay? It is a good habit to get into to be not writing things with negative exponents in your answers, because as we proceed through the course, this will make your life easier. If you have a fraction in the question, I would rewrite it as a negative exponent to start. But in your answer, leaving it as a negative exponent is not always good because you sometimes have more math you need to do here. Okay. Same goes for radicals. I would rewrite this as an exponent. So just a reminder, if you have a square root, this is an exponent of 1/2. If we had a cube root, this would be an exponent of 1/3, etc. Okay. So again, if I find y prime, I'm going to bring the exponent down. So my 1/2 is now in front. I need to reduce my exponent by 1. If I do 1/2 minus 1, I get -1/2. Again, if I want to write this as a positive exponent, this would give me 1/2x to the 1/2. The 2 is already on the bottom here. So this is a difference between this one and C. The 2 was not on the bottom of the fraction in C. That's why it stayed on top. This one, the 2 is on the bottom of the fraction. It's going to stay on the bottom. Or we can rewrite this, if we'd like, as 1/2 and put it back as a root. Now, you guys have done this exact question with your limits many times. We did it in our notes in 2.8 part 1 with our limit as h approaches 0. And we had an x value of 16 for that question. And you even did this on your test in chapter 2. So you have seen this question, but now look how much faster that is without having to do the limits. Okay. We also have something called a constant multiple rule. And what that says is if you have a constant in front of your function or in front of your term, you can factor that out before finding the derivative. So what that looks like is if I wanted to find the derivative of 3x to the power of 6, what that is that's asking me if I wanted to find the derivative, being asked to find d dx of f of x, which would be the same as finding the derivative of 3x to the power of 6. And the constant multiple rule says we can take that 3 out and find the derivative of x to the power of 6. Okay. And when we do that, what that is this would be 3 times, and the derivative of x to the power of 6 would be 6x to the power of 5. And this is the same as 18x to the power of 5. Now, this is f prime on the left. The derivative of f is f prime, which in this case is 18x to the 5. Now, if you look back at the question, you'll notice if I just simply dropped the x down at the very beginning, 3 times 6 is 18, and then my x was reduced by 1. So I'm not going to go through all of these steps every single time. What I'm probably going to do, which I will do with b, is first I'm going to rewrite b as 4x to the -3. If I want to find f prime, I'm going to drop the exponent down and multiply it by my constant because it's a constant multiple. That 3 multiplied with my derivative before. So I'm going to drop that -3 down, multiply by 4. That gives me -12. X. If I reduce that by 1, I get -3 minus 1, which gives me -4. Again, I can choose to rewrite this as a positive exponent by leaving this as -12 over x to the power of 4. Now, all of these rules put together are going to help us find the derivatives of exponent or polynomials, sorry. So the sum and difference rules simply say that if you have multiple terms being added together, you can find the derivative of each of those terms and add them together. Okay. So the long way of writing this, which again, you would never ever do this, would be if I found dy dx. This is the same as finding the derivative of 5x cubed minus the derivative of 6x squared plus the derivative of 4x. And then we could use constant multiple rule to take things out, or we could then write this as bring the 3 down. This gives me 15x squared minus bring the 2 down. This gives me 12x plus the derivative of 4x would be 4. Because technically this is 4x to the power of 1. Bring the 1 down, you get 4, and you have no x's left. That first step there, you're never going to write that out. You would not bother. Okay. We could also write this as y prime. Okay, that would be the same notation. The reason I use dy dx is because that's what the question said here. Okay. So the last one here, if I found dy dx, again, I'm not going to write out all these ddx's. I'm just going to go forth and find my derivative. First term, I bring the 5 down. I'd get 10x to the power of 4. Bring the 5 down and reduce my exponent. Minus 12x to the power of 1 plus 7. And remember, the derivative of a constant is 0. So the 8 you're not going to use. Derivative of a constant is 0. Okay. Again, practice questions. There's way more here than you would need to do. Pick some, try them until you're comfortable with doing these on your own. And that's it. Short lesson for today.